Every scientific theory is only a projection of the truth. It's never the truth. No scientific theory can ever be a theory of everything.
What does it mean as a philosopher interested in the ultimate nature of reality that our basic science is just equations?
We're not seeing the truth. Evolution is an artifact.
Our basic science isn't really telling us that much about what fundamental reality is.
Professor Donald Hoffman and Professor Philip Goff are both renowned in their respective fields of cognitive science and philosophy. Hoffman is a cognitive scientist who has put forward a theory called the interface theory of perception, which states that human perceptions are akin to some user interface shaped more by evolutionary survival imperatives than by an accurate representation of the external world. Thus, according to Hoffman, reality as we know it is some illusion. In contrast, Professor of Durham University, Philip Goff, is known for panpsychism, and so there's plenty of contrasting agreement in different words in today's theolocution, as well as disagreement, primarily around the universe's fine-tuning for life, as well as suggesting that, hey, they both agree consciousness is fundamental, but that doesn't mean that what's derived from consciousness is illusory. Quite the contrary. Philip has just published a book called Why? The Purpose of the Universe, and the links to that are in the description, as well as his previous works, Galileo's Error and Consciousness and Fundamental Reality. Even though Professor Goff is known for panpsychism, his views are best described as cosmopsychism. This means that the universe itself might be a conscious entity with its own goals. My name's Kurt Jaimungal. If you're new to this channel, this is Theories of Everything, where we explore theories of everything, primarily from a physics perspective, that is an analytical one, but as well as trying to understand, okay, if there is no toe, if there is no theory of everything, why? That to me counts as its own, a limiting theory of everything, or perhaps a theory of a thing, what constitutes something as separate from another thing. We've explored that with Carl Friston and Michael Levin, as well as what is free will, how do we know if we have it, what are alternatives to compatibilism and libertarian notions, and of course, how are we conscious? That is the hard problem of consciousness. Solutions to that, is it idealism? Is there something to Cartesian dualism or some other form of dualism? How about a triadic model? All of these are explored in depth with rigor on this channel by interviewing some of the top intellectuals in this space. If that sounds interesting to you, then feel free to subscribe, as we have 2-hour, 3-hour, 4-hour, sometimes even 8-hour long podcasts with a guest. There are also clips released every single day. There's a new video, so if those Brobdingnagian podcasts are a bit too much, well, hey, get a teaser by listening to a 5-minute section or a 10-minute section. Either way, enjoy this theolocution with Philip Goff and Donald Hoffman. Okay, well, it's an honor to host you both. Thank you, Professor Goff. Thank you, Professor Hoffman. Hoff and Goff.
Thank you, Kurt.
Prof. Hoff and Prof. Goff. Great to be here.
So, Prof. Goff, you have a book that's recently been released called Why? What is it about? And please tell myself and the audience the relevance of it for this discussion.
Brilliant. Good question. So yeah, this is a book I would never have imagined myself writing about 5 years ago. It's been quite a journey. I think so many people in the West think they have to fit into the dichotomy of either you believe in the God of traditional Western religion or you're a secular atheist. You know, it feels like you've got to say, whose side are you on, Richard Dawkins or the Pope? And, I was raised Catholic and decided I didn't believe in God when I was about 14 and gave that one up and was quite happily on Team Secular Atheist for over 20 years. But just recently, I've slowly come to think that both of these worldviews are inadequate. Both of them have things they can't explain about reality. And ultimately, where I think the evidence points is to what I call cosmic purpose, namely some kind of goal-directedness at the fundamental level of reality, but existing in the absence of the traditional God. So basically in this book, that's Why? The Purpose of the Universe. It's got a very cool cover, actually. I'm quite pleased with what they did with that. And I argue for this position and then discuss its implications for the meaning and purpose of human existence. So just basically a very brief overview. One of the things I think the traditional atheist picture of a meaningless, purposeless universe struggles to explain is the fine-tuning of physics for life, the recent discovery that for life to be possible, certain numbers in physics had to be against improbable odds just right. And, for a long time, I thought the multiverse was the best explanation for this. But I've just been slowly persuaded by philosophers of probability that there's some dodgy reasoning in the inference from fine-tuning to a multiverse, that it commits what's called the inverse gambler's fallacy. And so I've just been led to think that actually in our standard Bayesian ways of thinking about evidence, the fine-tuning just is evidence for cosmic purpose, for this kind of goal-directedness towards life. And that's kind of weird. And I think as a society, we're sort of in denial about this at the moment because it doesn't fit with the picture of science we've got used to. It's maybe a bit like in the 16th century when we started getting evidence that we weren't in the center of the universe, and people struggled to accept that because it didn't fit with the version of reality they'd got used to. And now we sort of scoff at those people and we think, oh, those stupid religious people. Why didn't they just follow the evidence? But I think every generation absorbs a worldview it can't see beyond. And I think something like that's going on with fine-tuning right now. So it's not just fine-tuning on my case for cosmic purpose is built on. There's also a chapter on consciousness and the mind-body problem connecting to AI and the science of consciousness. And I think certain things in this area also point to cosmic purpose, although the argument there is takes a little bit longer to lay out. So that's the case for kind of cosmic purpose. Now, most people arguing for cosmic purpose go for God. God's fine-tuned the universe or something, but I don't like that hypothesis either. And here it's the familiar reason that the difficulty of reconciling an all-loving, omnipotent God with the terrible, gratuitous suffering we find in the world. I just don't, it doesn't make sense to me that a loving God who could do anything, would create a universe with so much pain. So basically, I think atheists can't explain fine-tuning and some consciousness stuff. Theists can't explain suffering. We need a hypothesis that can account for both of these data points. And it just very, very finally, just the style of the book is, so my first book, which is somewhere here, was an academic book. My second book, Galileo's Error, was aimed at a general audience. So this book, I'm trying to do both. So it's with a academic press, Oxford University Press, so it's kind of properly peer-reviewed. But it's also set up as a trade book, so it's reasonably priced, unlike academic books. But also each chapter has a more accessible bit and then a digging deeper bit, which goes into some of the more technical details and all the objections and so on. So yeah, so maybe it'll please no one, but I'm uniquely trying to appeal to both of those audiences. But yeah, that's about it, really. Sorry, that was a bit long-winded.
Wonderful. And what is it that you appreciate about Don's work?
I'm a huge fan of Don's work. I mean, I think Don is a radical pioneer. I think humans always think they're at the end of history, and that the current paradigm is basically established, and the task is just to fill in the details. And I think in every period, most people go along with that. Largely because people look at you funny if you don't. But I think Don has come up with some profound challenges to our prevailing materialist paradigm, and he's done so not just with science and mathematics, but also I think with engagement with philosophy. I think we're living in a sort of scientistic period where people think all questions can be answered with experiments, and they've forgotten the role of philosophy, the very important role of philosophy in the project of finding out about reality. And I think especially with consciousness, it's so important for science and philosophy to work hand in glove. And it's just wonderful to see that in Don's work. And yeah, it's stimulated me a great deal.
Don?
Well, thank you, Philip.
What is it you appreciate about Philip's work?
Well, I actually wrote a little blurb for his wonderful new book, and I think it's an outstanding book. It's easily accessible to an average non-scientist, non-philosopher, but it's also something that a scientist and a philosopher will find quite grabbing and challenging. So it's brilliant to be able to write about such deep issues in a way that the average non-scientist and philosopher can understand and yet engages everybody else. So hats off to Philip for a remarkable book and for doing that, and also just for the way he engages with very difficult questions and is not afraid to go against the standard views where he thinks he needs to go against them, and that's not easy to do in academia. It's just not easy to do. And especially in philosophy, it's very, very difficult. In science, you might be able to say, "Well, I've got a theorem," so you come at me because I've got a theorem. Whereas it's a little harder. I mean, sometimes you can have a logical proof in philosophy, but short of that, then it just is a lot of bravery to go out there and say, "Here's a different point of view," and then to take all the comers. And so, hats off to Philip for doing that. And I must say that I really enjoyed learning a lot about the philosophical issues in his latest book, Why. So that's very, very, very helpful. And one thing that philosophers do is remind scientists to think about our basic core concepts, to look at the logical structure of what we're thinking about, not just jump in with the mathematics and go off and compute and so forth and derive consequences, but to think at a fundamental level about the very concepts that we're using at the foundations of our theories and to think about that conceptually. And so I really appreciate Philip pushing me around in the conceptual space on the very scientific topics that I've been engaged with for decades. So that's, again, much appreciated.
Thanks so much, Tom.
I know you have a question I know you both have several questions for one another, and I'll just state one of them to you, Don, and then we'll hear your answer, and then you'll ask the same question to Philip. The question is about neurons and whether they exist prior to being perceived, and same with space-time and elementary particles.
So you'd like me to answer my own question first?
Yeah. What is your point of view on that? And then we'll get Philip's answer.
Right. So first I'll say what I think the standard view is, so I can contrast my view with the standard view, which most of my colleagues in cognitive neuroscience just take it for granted that, of course, neurons exist when they're not perceived, and that neural activity and brains more generally are responsible for conscious experiences in humans and perhaps other animals as well. And maybe if you have the right programming and circuits and software of some AI, it'll eventually be conscious as well. So this approach to consciousness that says neurons exist when they're not perceived and neural activity is responsible for the generation of consciousness, I think runs afoul of modern science, modern physics in particular. That the Nobel Prize in 2022, last year, was awarded to 3 physicists for confirming experimentally what quantum theory seems to predict theoretically, that local realism is false. The local realism is the claim that, realism is the claim that objects have definite values or properties like position and momentum and spin when they're not observed. So the electron has a position even if no one looks. And locality is just the particles obey Einstein's space-time laws. Things can't travel faster than the speed of light. Influences. So local realism is false. And I think that we should recognize that local realism is false. Neurons simply don't exist. They don't. Well, put it this way: they don't have any position when they're not observed. And if something doesn't have a position, it's not there, right? If you don't have a position, you're not there. So I would say that neurons simply, that right now, I don't have any neurons. And someone who's hearing my argument might say, yes, I completely agree with you now, that you don't have any neurons. But I'm saying I don't have any neurons. If you opened up someone's skull, you would find neurons, but you would be creating them on the fly when you observed. And that's, again, in line with what quantum theory says, is that these particle properties emerge in the act of observation, and they're a result of the observation, but they do not exist prior to the observation. And there are, by the way, in quantum theory, cases where you can set up empirical, experimental situations where you can prove that if you make a certain measurement, you'll get a certain outcome with probability 1. And you can also prove that outcome could not possibly be there until you made the observation. So I'll say that again. You can prove in these special, and if you want to see the paper on this, it's Chris Fuchs. It's 2010 paper on quantum Bayesianism. He goes into this. So you don't have to rely on me. You can read that paper and read for yourself. A quantum experiment that gives you a case where you can prove that you will, if you make this particular measurement, get a certain value with probability 1. Probability 1. But you can also prove, given the detailed setup of the situation, that it's impossible, logically impossible, that the value of that outcome existed prior to the measurement. So this is what you can set up in quantum theory, and that's why a lot of people realize that local realism is false. And it took the Nobel Committee decades before they gave the Nobel Prize for it, because this is a big one, right? So they had Clauser did a lot of work decades ago, and then they were tightening, closing the loopholes and so forth. And finally, the Nobel Committee said, "Okay, what can we do? This is pretty." So I think that it's just in keeping with what physics is telling us to let go of local realism for neurons. And so I would say no. Neurons do not exist when they're not perceived.
Philip.
Yeah, so I think Don and I have more in common than that divides us. Crucially, our fundamental starting point is that consciousness exists at the fundamental level of reality. Well, I don't know if it's a starting point, but it's a crucial aspect of our view. I suppose where this first question gets to the heart of maybe where we disagree, namely on the status of physical reality. So I think Don, he can speak for himself, but defends a view that philosophers have traditionally called idealism, which usually comes with the idea that the physical world is illusory in some sense or not fully real. Whereas I guess I'm more inclined to the view that the physical world is entirely real and independent of our minds. This Batman cup is really out there in the world and lights bouncing off it, and it's made up of particles or fields or whatever. It's just that those particles and fields are ultimately made up of consciousness in ways we could perhaps get into. But and I suppose that the reason I'm there is, I'm totally open to Don's position. So I suppose my view is sort of, I'm in a way a middle. I always go for the middle ways, a middle way between the physicalist or materialist position and the idealist position. I'm open to Don's position, but I suppose I'm just not totally as yet persuaded by his arguments, as intriguing as they are. Don often appeals to these speculative theories popular, not fringe at all, popular theories in theoretical physics, according to which space and time don't exist at the fundamental level of reality. They're rather emergent. But I organized a conference on panpsychism in the States, and Don kindly gave a talk, and Sean Carroll was the in-house skeptic of all this business, and Sean's response to Don that I kind of agree with is, just because space and time don't exist at the fundamental level of reality doesn't mean they're not real, right? It's we discovered atoms are not fundamental; they're made up of quarks and electrons. That doesn't mean we say, oh, there's no atoms. We just say that they're not fundamental. So I'm not on the local realism. This is going to quickly get outside of my skill set, but my understanding, talking to people like Tim Maudlin, is that none of this rules out for the Bohmian view, for example. Although I know that's not an incredibly popular view, but even if you go for a more popular interpretation of quantum mechanics, we don't have to crudely think particles are the fundamental things. It could be, the wave function is the fundamental physical reality. Sean Carroll tells me he believes in the fundamental reality as a vector in high-dimensional Hilbert space. So we could have some esoteric fundamental physical reality, but which three-dimensional space and time emerges from? This is a heated debate in philosophy of physics. The popular view, I think, is that people like David Albert, Alyssa Ney, try to make sense of three-dimensional spatiotemporal mind-independent reality being real and genuinely emerging from the more non-space-time, esoteric, maybe quantum wave function reality that physicists currently are inclined to think is at the fundamental level of reality. So maybe the normal world we perceive is real but emergent.
Don, it would be useful at this point to characterize the definition of real.
Great points, Philip. Of course, great points. So, the word real, right? We use the word real in a couple different senses. And so maybe we want to distinguish a couple of senses of real. So one version of real is something is real if it exists even when it's not perceived. And I think that's what perhaps you were saying. But there's another sense in which something is real. For example, if I have a headache and I complain about this nasty headache that I've got, that headache wouldn't exist if I didn't perceive it, right? So my headache isn't real in the sense that I just gave before, that it would exist even if it weren't perceived. And nevertheless, someone might say, well, if you don't say my headache is real, I beg to differ you. My headache is real. So there's a sense in which something is real if it's a real subjective experience, and we in that case we know that the word we're saying something's real not because it exists even when it's not perceived, but rather it exists in my perception. And so the question about are neurons real is I'm really asking, are they real in the sense that they would exist even if they're not perceived? And I think your answer is yes, they are real in the sense that they would exist even if they're not perceived. And I'm saying no, that they're only real in the sense that they are subjective experiences that we have. And so they exist while we have the experience and they don't exist otherwise. Okay, so just that notion of real, because people can wobble on that and get confused on what we're discussing. So then my take on it is, of course, physicists are going to debate, and Sean Carroll doesn't think that we need to worry about space-time is doomed. So we'll have to see where the physics goes in this. But here's what I see happening in the last 10 years. For the high-energy theoretical physicists who are working on this, they're finding that space-time. So what they argue is that space-time is doomed because it has no operational meaning at 10 to the minus 33 centimeters, the Planck scale. And it's not that there are pixels at 10 to the minus 33 centimeters. It's that space-time makes no sense anymore. There's nothing you can do operationally with it. From my point of view, it's a fairly shallow data structure. It falls apart at 10 to the minus 33 centimeters, not 10 to the minus 33 trillion centimeters, just 10 to the minus 33. And it's useless after that. And 10 to the minus 43 seconds, not 10 to the minus 43 trillion seconds, 10 to the minus 43. So it's a fairly shallow data structure. And so in the last 10 years, physicists have been saying, well, what happens if we let go of space-time completely? And also quantum theory completely, and look for some deeper structures beyond space-time and quantum theory. Can we find anything that can actually do work, like predict scattering amplitudes of particle collisions in the Large Hadron Collider and so forth? And in the last 10 years, so this is all relatively new, they've discovered that, yes, you can, that you can actually, there are these new structures like decorated permutations and amplituhedra that lets you compute actual scattering processes in space-time. And they have two advantages. What they've discovered are two advantages over space-time physics. One is that, first, if you do it inside space-time using quantum field theory, just to compute one interaction, like two gluons hitting each other and four gluons spraying out, is hundreds of pages of algebra and millions of terms. It's a mess because you're doing it all on quantum fields in space-time. You're enforcing quantum theory and relativity theory. When you let go of space-time and these new structures, you can do what was millions of terms in 3 or 4 or 5 terms. You can compute it by hand. So the math all of a sudden becomes simple. Well, simpler. Physics is never easy, but simpler. And the second thing is you see new symmetries. There's something that they call the infinite Yangian symmetry, which you cannot see in space-time. But when you let go of space-time, all of a sudden you see not only does the math become simpler, but you're seeing new symmetries that are true of the data that can't be seen inside space-time. So what seems to be emerging is that space-time, which we've taken to be the fundamental reality, looks more and more like a, frankly, pretty shallow, tired data structure that is a really bad framework. We're sort of stuck with this data structure in terms of our perceptual way we perceive the world. And so what physics is doing is now realizing we don't have to be stuck with either quantum theory or special or general relativity. We can go beyond them. And we can then project back into those space-time data structures and get answers much more easily and see deeper symmetries. So it's in that sense that I'm thinking, space-time is like flat Earth. It's good for some things, but if you're trying to build a space program, flat Earth isn't going to do it. And if you really want to understand the nature, and space-time is great for certain things. But if you really want to understand the nature, I think, of consciousness and of reality more deeply, a data structure that falls apart at 10 to the minus 33 centimeters is not a good candidate for, and I certainly wouldn't want to be stuck with that really shallow data structure in my thinking in terms of these deeper questions. So,
Okay, Philip.
Well, I suppose, again, I think all of what you've said builds a case. And I couldn't get into the physics of debating that case, but a case that space-time is not fundamental. The fact that our models seem to collapse below certain levels suggests they're of limited applicability, and hence that they don't exist in the fundamental story of reality. I mean, you said Sean Carroll's not sympathetic to space-time being doomed. Well, I think he is. If by space-time being doomed, that's just a sort of poetic way of saying it doesn't exist in our fundamental story of reality. And but yeah, I still think. Suppose we think space-time is emergent, and what we have at the fundamental level is the wave function. I mean, there's going to be, I presume, a sort of mathematical mapping from the wave function to any state of affairs in ordinary, quote unquote, three-dimensional reality. And so on that basis, we can perhaps make sense of some kind of emergence relationship, or philosophers tend to call this grounding. Scientists tend to talk of emergence. But yeah, I guess I don't see why this means neurons can't exist unperceived. Why can't we just say they exist unperceived, but their existence, when unperceived, is ultimately rooted in a more fundamental story that is not spatiotemporal, for all the reasons you've raised. But yeah, I suppose that's what I think.
Okay, great. So that's a good response. I would say a couple things on the quantum theory aspect of it. What these high-energy theoretical physicists are saying is that not only is space-time doomed, but quantum theory is doomed. So that we're not going to get space-time emerging from wave functions, and the new structures that they're finding, like the amplituhedron, the physicists will say, look, there are no Hilbert spaces here. These new structures, there's no Hilbert space anywhere to be seen. But we can show you why quantum-like features like unitarity emerge from these deeper structures. So these deeper structures don't care a bit about Hilbert spaces or quantum theory, but you can show how these give rise to unitarity and other quantum-like features at the same time that they give rise to the space-time kinds of features. And another thing about the quantum theory is when you look at the weirdness of quantum theory, for example, the no cloning theorem, right? You can't copy quantum bits. And things like superposition and entanglement. The sort of the weird aspects of quantum theory. There are a number of physicists who pointed out that these properties of quantum theory can really be understood as just arising from lack of information. Just when you have it's in some sense just due to partial information and you can prove that alone is responsible for these weirdnesses. So, and that makes sense if space-time is just, I like to view it as just a headset. It's just a data structure. It's just a data structure that humans use to navigate the world. And we can talk about the evolutionary arguments that I have for that. But that data structure is there to simplify, right? That's the whole point of an interface, is to simplify and throw out information. So all quantum theory, really all the weirdness of quantum theory is pointing again to the fact that space-time itself is a very shallow and information-losing data structure. And so when we let go of space-time, we're also going to have to let go of quantum theory, because quantum theory is really a symptom of the limitations of space-time. So
yeah, I mean, I didn't mean to say, this fundamental theory is going to be quantum. I mean, I was just to use the wave function as an example. I suppose just, what you capture in terms of, well, it's just a data set. It's just a sort of headset we're wearing. It's a way of, I don't see why we couldn't, instead of that, use the other very detailed theories of emergence people have talked about that often are to do with losing information and a less fine-grained picture of reality, or maybe involving what Dennett calls real patterns, or some kind of functional story. David Albert and Barry Lower developed some kind of functionless story of how we get three-dimensional reality out of more esoteric structures. So, yeah, I just don't see why... It's almost like you think the only way of making sense of the non-fundamental is this sort of data structure business. But, I mean, maybe that's one possibility, but there's also other models of emergence. And so it could be, neurons are real, but they are emergent from these bizarre structures like I can never pronounce this, what is it, the amplitudehedron or something, so they're just, their existence is dependent on those more fundamentally structures. So, yeah, I mean, I guess I just think of these as different models of the non-fundamental, and I would be looking for an argument as to whether to go your way rather than David Albert's or Tim Maudlin or whatever. But yeah.
Fair enough. I would say that so far the other kinds of attempts haven't, for example, unified gravity with quantum theory, right? So they're promissory notes that haven't yet been fulfilled. But so we can't point to a success yet in the emergence.
Hold on, Don. Sorry to interrupt, but they're different fundamental theories. I'm not advocating a fundamental theory in physics. I'm just talking about different views of the non-fundamental and the relationship between the non-fundamental and the fundamental. It seems like you think your conception of the non-fundamental is always like it's a data structure. But so I'm not a physicist or even a philosopher of physics. I don't know what fundamental physics is going to look like, but I guess I'm not seeing why we can't, whatever it looks like, even if it's the amplitudehedrons that I can never pronounce or whatever. I should have rehearsed this, shouldn't I? Learn how to pronounce that.
It's basically like amplitude. Just forget the D. Amplitude, and then just say hedron.
Amplitudehedrons. Oh, thank you. What now? Why didn't I ask you that before we went live? Anyway, everyone thinks I'm an idiot now.
Yeah, but those people don't have any neurons, so don't worry about it.
So yeah, whatever fundamental physics is, whatever kind of funny structures are at the bottom there, I don't see why we can't make sense of space-time as emergent from those non-spatiotemporal structures. But
we can, in the same way that we can get some kind of relationship between, for example, Einstein and quantum theory versus Newton, right? And we can show that Newton is a special case of Einstein. If you let the speed of light go to infinity, or if you let Planck's constant, in the case of quantum theory, if you let Planck's constant go to zero, then you can get, versions of Newton as special cases of the deeper theory. And that's the sense in which I'm thinking about these structures beyond space-time, is that we'll find that space-time emerges as a special case of a much, much deeper and richer. So, I mean, for example, we can still use
I'm happy
Newton.
with all that. I'm
Yeah, I
happy
think we're on
with
the same page.
everything you just said. I'm
Yeah,
happy
I
with
think we're on the
everything
same
you
page.
just said. But then no, hold on. But then you go, okay, so it's data structures and it's the headset we're wearing and they don't exist when they're not perceived. I think that's a sort of non sequitur. That's a further step from everything you just said.
Sure,
I don't know.
that's another step
Yeah.
in the sense of going with the local realism being false, right? There I'm saying, I mean, the Nobel Prize was just given last December for local realism being false, and so I believe the physics. Local realism is false. End of story. That's the way. Now there are some physicists who will disagree. There's some who will say there's superdeterminism as a way out. So look, we can have, if we can keep local realism if we assume that there's superdeterminism or something like that. So there are issues about this, but there's something I think that we might have in common here that I'd like to push on, and that is the physicists who are looking for structures beyond space-time are right now just finding geometric objects. The apple tetrahedron is not a polytope, but it's a geometric structure, and decorated permutations are combinatorial data, mathematical structures. But there's no dynamics, and ultimately we're going to have to say when we step outside of space-time, physics likes dynamics, and we're going to be talking about dynamical entities beyond space-time. Not inside space-time, not curled up inside space-time, dynamical entities outside of space-time. Now, here's the perfect place for you and me to say, hey, well, what about consciousness, right? What about conscious entities entirely outside of space-time? And that's where I'm working with my own theories and saying, okay, let's just go with this. The Nobel Prize was correct. Local realism is false. Space-time is not fundamental. And we need to find dynamical entities entirely outside of space-time. They will project into space-time, of course, just like Newton is a projection of Einstein and quantum theory. So, but it'll be a special case of some deeper structure. So why not go after a theory of consciousness, the dynamics of consciousness that's not tied to space-time physics, but has the important constraint that whatever theory of consciousness we come up with outside of space-time, whatever dynamics, we must, with mathematical precision, show precisely how space-time arises as a special projection, and all the dynamics of particles and all the dynamical laws of physics inside space-time emerges as a very, very special case of a far more general dynamical system of consciousness. And that would turn the whole tables around. Instead of saying, we're trying, of course, we know that space-time is, objects in space-time are real and the laws, and we're trying to fit consciousness into that, to say, no. That is the relatively trivial thing. The deeper thing is consciousness itself. We can get a mathematical theory of consciousness, qua consciousness, and show a projection in which space-time emerges as a fairly trivial example of a far richer dynamics of consciousness. Now, of course, we have to do it, right? We have to actually give the precise mathematical laws and get the precise predictions. But if we could do that, that would change the whole thing around. Consciousness would not then be a second fiddle to things in space and time, or just an equal fiddle. It would be, in fact, the real story, and space-time itself would be a projection of this much deeper story. I would think you would like that kind of story.
Yeah. Well, I suppose we're coming back to this, the sense in which the point of agreement between us that there's consciousness at the fundamental level. Maybe we have slightly different stories to fit this in. What do you think, Ed? Should we move on to some of the other questions, or should we continue on back and forth with this?
So I would prefer that we not stick to the physics, but instead stick to the philosophy. Philip, if you don't mind. Don, I have some quick objections just from a physics point of view, because I just can't let them go. So number one, when someone says the physicists are finding these phenomenon, it's not the physicists. There are maybe 30 of those physicists, of the 30,000 that exist that follow NEMA's program. Like it's a minority, maybe 25 people do. And then number two is that the amplituhedron doesn't capture non-perturbative effects. So confinement isn't there, and almost all of the world is non-perturbative. We don't know how much is perturbative. And number three is that, okay, just because something simplifies calculations, even if drastically, it doesn't imply an ontological reality to the ingredients that go into the simplification. So for instance, there are two billiard balls that bounce off one another. We can model that with trillions and trillions and trillions of calculations and pages that take into account all the subcomponents and substances inside this billiard ball and the paint and the reflections. Or we can just take their center of masses and have them bounce off one another. That doesn't mean the center of mass is more real than all of the components that make it up. And now number four is that the Nobel Prize was given because of local realism or disproving realism or local realism. However, this is just something that's said in the popular press. And when you interview the people who have won the Nobel Prize, they're not anti-realists. In fact, they'll say that Bell's theorem doesn't assume realism because Bell's theorem is a mathematical theorem, any more so than Stokes' theorem assumes reality, quote unquote, or the triangle equality assumes reality. Like there's no axiom of reality. Okay, now the next one, and apologies if I'm going on for too long, but the positive geometry of NEMA assumes not only supersymmetry, which is dubious, but extended supersymmetry, so a perverse form of it, n equals 4, if I'm not mistaken. And furthermore, you mentioned that the theories don't incorporate gravity. Well, neither does NEMA's. Okay, lastly, if we're to take it to be the case that if we are to probe the Planck length, then we'd create a black hole, well, one, what's wrong with creating a black hole? Black holes exist. Number two, if that was to mean that somehow the Planck length doesn't exist, well, that's an operationalist view on reality in the same way that we can say the inside of a black hole doesn't exist because we can't observe it. There are many other views on what existence is other than operationalism. So I'm done. Those are just some quick objections. Don, I'd love to hear your thoughts.
Well, I think that those are all very, very good points. So, for example, the amplituhedron assumes n equals 4 super Yang-Mills. So it's supersymmetry. It's only for massless. That particular one is only for massless particles. And you're right that it doesn't extend gravity. So this is fairly new work. There's some papers in the last couple of years where NEMA has gone to all masses and spins. So it's not just, but I think it still involves supersymmetric ideas, and that may end up being false. We'll have to see. What's interesting though is this has only been at it for a decade. You know, literally going after this stuff, structures beyond space-time, and we're finding interesting stuff, and it's I think very encouraging. Of course, there's limitations to what we found, but it's really quite encouraging. And I agree as well that there are physicists who think that the experiments that got the Nobel Prize don't count against local realism. Some think that it shows that we're in a world of superdeterminism. So all of your points are well taken. It's a matter of the final answer is not in, but I'm suggesting that there's this interesting direction that is coming out of the new physics, and ultimately physics is going to look for some dynamics of entities beyond space-time. And that is interesting. When we talk about dynamics of entities outside of space-time, what kinds of entities are those? What are we going to put there as the entities? That is, so that's that's ultimately what I'm exploring here is what happens if we start with entities that we take just to be consciousness, and we get a precise mathematics, and we can show that we can boot up all of space-time and quantum theory from that. It wouldn't prove that this is the right framework, but it sure is intriguing, right? As a scientist, it would be very, very intriguing. And it would raise deep philosophical issues. I mean, what kinds of entities beyond space-time are we talking about here? These are no longer physical entities. They're not in space-time. What are they? So we're going to have to ultimately, if we find a physics beyond space-time, and it's a dynamical system, we're going to have a theory about what those entities are like. What are they about? And why is there this dynamics going on? Of course, it'll be open to us to give a non-conscious approach, of course.
Philip, I have a question. When Don was saying, look, the neurons don't exist, which I'm just going to pick up this pen and say this pen doesn't exist prior to looking at it. Sorry, prior to observation. And then you were saying, no, it can exist. But at the same time, this is made out of consciousness. Can you not reconcile those two views by saying the pen is observing itself because the pen is made up of subjective experiences? Like, is there a way to make the objective from the subjective?
Well, I wouldn't say that. I wouldn't quite put it that way that the pen is observing it. Well, I mean, maybe I could talk a little bit more about the inspiration for the contemporary panpsychist resurgence, which very much draws on crucial work from the 1920s by Bertrand Russell. And it was sort of the...
Sorry to interrupt. It would also be helpful if you were to distinguish it from idealism, panpsychism.
Yeah, sure. Let me do that. So it's very much the somewhat rediscovery of this crucial work from Russell, particularly in the analysis of matter, that has made panpsychism in the last decade go from something that was laughed at insofar as it was thought of at all to being a serious academic option that's taught to our undergraduates, published on, and so on. So what I think this connects a lot to what Don was saying as well. So what Russell was thinking very hard about in the 1920s was that the fact that our fundamental science, physics, is just purely mathematical, right? Something we kind of take for granted. And of course, that's very useful if you're a working physicist. You can get very precise predictions and so on. But Russell's thinking, what does it mean as a philosopher interested in the ultimate nature of reality, that our basic science is just equations? And what Russell concluded is that what it means is that our basic science isn't really telling us that much about what fundamental reality is. It's merely describing its mathematical structure. And so as far as physics is concerned, fundamental reality could turn out to be anything. As long as it has the right mathematical structure, you're going to get physics out of that. That's all physics cares about. So the contemporary Bertrand Russell-inspired panpsychists exploit this, and the idea is that what we have at the fundamental level of reality are very simple conscious entities, networks of simple conscious entities interacting in very simple, predictable ways. Through their interactions, they realize certain patterns, certain mathematical structures. And then the idea is those mathematical structures just are what we call physics. So we sort of get physics out of underlying facts about consciousness. So I don't think you can get consciousness out of physics, but I think you can get physics out of consciousness. I think we know that can be done. I think we should think of Russell as the Darwin of consciousness. I think he essentially solved all the mysteries here. So really, but what this ends up as, and this is where I think it maybe contrasts with what I think of as Don's idealism, is that there's a kind of identity between consciousness and physical reality. As I sometimes put it, matter is what consciousness does. Really, there's just consciousness stuff, but physics is the mathematical structure of that consciousness stuff. As Stephen Hawking said on the last page of A Brief History of Time, physics doesn't tell us what breathes fire into the equations and makes a universe for them to describe. For the Russellian panpsychist, it's consciousness that breathes fire into the equations. So I just connecting it to what Don was saying, I mean, Don seems to have this idea that like this physics he's attracted to, or this new physics, makes it more problematic to, we need to look elsewhere than space-time. We need to look for new entities. But from my perspective, my Bertrand Russell-inspired perspective, physics has never told us ever what reality is like. It's just a bunch of maths. It's not, unless you go for Max Tegmark's view and think, the universe is made up of maths, then physics just is not in the business of telling us what has never been in the business. So it doesn't matter whether, the amplituhedron ends up being the right stuff or whether we get Bohmian space-time. It's just maths, and we'll always need something to fill out that mathematical structure, something to breathe fire into the equations. And for the panpsychist, well, the most parsimonious answer is consciousness, because we know consciousness exists. I think there are good reasons to think if you put just mathematical structure at the fundamental level, you're not going to be able to get consciousness out of that. But we know it can be done the other way around. And so that seems to me the more plausible view. So yeah, so that's kind of how I think about things. Does that make sense?
Yeah, and everything you said, I agree with. So the only place where I would sort of go take the next step is to say, why just the laws of physics? Why not the consciousness? Why should we restrict our imagination to say that the laws of physics that we happen to know are all that consciousness has done? Why not say that there are an infinite number of other quote-unquote physics that consciousness chooses to play with? This is just one. Space-time physics is one, perhaps more trivial kind of physics that consciousness has chosen to make. Why should we put ourselves in a conceptual straitjacket and only work with the physics that we've seen? In the amplituhedron, it is parameterized by three integers, n, k, and m. And m is basically an integer that it dials up the different universes that you might choose. So with the amplituhedron, you can have our four-dimensional spacetime as the projection of this deeper structure, but you can also have an eight-dimensional spacetime. You can have spacetimes of 20, 30. In other words, you can already, with the new physics that they're finding outside of spacetime, you can choose which kind of spacetime universe you want to create. And our 4D one is just one of an infinite number of possibilities. And so already the physics in just the first decade of stepping outside of spacetime is saying, whoa, the spacetime projection of this deeper physics is clearly just one of an infinite number of projections. I'm saying, okay, let's go with what the math is saying. Consciousness is not in a space-time straitjacket. It's free to have an infinite number of completely different kinds of physics with different kinds of laws, and for us to be wedded to the space-time one is to limit our imagination about what consciousness can really do and what it really is.
I suppose I'm very strictly an empiricist on this point. Even people might find that surprising, given my philosophical views. But as I say, for the panpsychist, there's a kind of identity between. So the panpsychist will say, sometimes people say to me, well, what's the kind of mathematics of your theory? And my answer is, ask a physicist, right? So for the Bertrand Russell style panpsychist, it's the job of physics to identify what Russell called the causal skeleton of reality. Physics, the job of physics is to identify the mathematical structure of reality, the dynamics, and then our philosophical interpretation of that is that mathematical structure is filled out by consciousness, and because I think it's the best solution to the mind-body problem. But it's just a question for physics, or more broadly an empirical question. What are you've talked about the dynamics of consciousness and the dynamics of physical reality. For me, they're just the same thing, right? And so, okay, these infinite causal structures of consciousness, maybe they're possible, but I'm going to want empirical reason to think they're actual. I'm going to look for empirical grounds from physics to tell me what the dynamics of consciousness are, which for me is just equivalent to the dynamics of physical reality, the reality physicists are trying to articulate.
Of course, I'm on the same page. Whatever theories we propose about dynamics of consciousness outside of space-time, and if I propose all these other kinds of universes, if quote-unquote physical universes, then I would want to try to find some kind of empirical tests. Absolutely. So I agree with you on that. It's just that I don't think that we should a priori rule out the possibility that there are many, many more ways that consciousness can give rise to quote-unquote physics than the one that we happen to know. And as we start to think out of that box, we may be able to find clean empirical tests of that hypothesis.
Yeah.
I'm finding it difficult to see where you disagree. So Is it, Philip, that, because it sounds like you all agree at your fundament that consciousness is at the fundament. But then, Philip, you believe Don is making a jump from there to something speculative and doing so with confidence? Or is it not that?
It's just that I suppose I'm happy to say this pen exists when we're not observing it. and I would say all the things about it a normal physicalist materialist would say. There's light bouncing off it, hitting our eyes. And yeah, I'm not... This talk of it's a data structure, that it's a headset we wear, I'm not fully seeing the motivation. I mean, maybe we should talk about the evolution stuff as well briefly, or which
Sure.
I guess is the other point where we disagree.
Maybe I'll just say
sure.
one thing in reply here, just because of what you said, just brought up another way that I might get at this.
Drink some wine.
And that is to say that if you think of consciousness as fundamental and that I'm having conscious experiences, so I'm having an experience as of a pen, right? You held up a pen. And I don't, if I take consciousness to be fundamental, I can say I definitely know that I have the conscious experience as of a pen. Now, someone might come along and say, but in addition to your experience, there really is, there is a pen, and not just your experience of a pen, there is a pen. And I say, well, I don't know what the evidence is for that. I don't really need it. I can completely do my physics without any assumption that there's anything but the experiences, and I can write down the equations and not. So I don't see why I need this extra ontological baggage of the real pen. And pound. There is a pen. When I pound the table, there really is a pen. Well, I have an experience, and that's all I really need. So why do I need the real pen? Why don't I just say local realism is false? There is no real pen, but there is a real experience, and that's all I really need. And as Einstein put it, the laws of physics just basically are there to show us how we can predict new experiences from old experiences.
Yeah, well, I suppose, look, we want a theory that fits together the story we're getting from physics and the reality of consciousness. I suppose they're the two data points for me. But I mean, maybe we could agree on the fundamental story. I suppose I just think a lot of philosophers and philosophers of physics have come up with detailed and rigorous theories of emergence where we can make sense of the pen, not as a sort of extra thing in the ontology, just something, maybe just to take Dennett's view that it's a sort of a real pattern or something in the more fundamental.
What is a real pattern in Dennett's view?
So we've got the you could know all of physical reality at the level of fundamental physics, all that detail, but that's not very useful for many practical purposes. And I mean, maybe this connects with what you were saying, Kurt, about sometimes it's not the fundamental thing that gives you the more information with less axioms or what have you. Some kind of ways of carving up reality. Dennett talks about the intentional stance when you treat something as an agent with thoughts and experiences, or the design stance when you treat something as a designed object. They can be more useful structures for prediction rather than trying to, work out from fundamental physics when your alarm clock's going to go off or whatever. But maybe it would help to connect to the evolution stuff. Should we go there now?
Yeah, please. And then also, you mentioned the word useful here, and I imagine, I don't want to speak for Don, but that Don would agree that sure, it's useful, but useful is a different statement than is it true or does it exist? I don't know.
Yeah.
I don't want to put words in your mouth. Don, sorry.
No, those are good.
Yeah. So then it starts to get tricky to see where the difference is, perhaps. But anyway, so this is I guess coming to Don's other argument, and we've been back and forth on this a little bit on my Mind Chat podcast. So Don's evolutionary argument that just very roughly, Don can articulate it for himself, but given that our senses are evolved for fitness rather than truth, we shouldn't trust them to tell us In fact, I think Donna said there's zero chance they're telling us the truth about reality. Well, I'm still a bit hung up with an objection. It's not my objection raised by philosopher Jeffrey Bagwell. It's actually published in quite prestigious philosophy journal, Synthèse, a paper called, what's it called now? Debunking Interface Theory. So what Bagwell presses on Don is that there's sort of something self-defeating about his argument, right? Because if our senses have evolved for fitness rather than truth, so we can't trust them, how do we know we evolved, right? We only know we've evolved because we can use our senses, look at fossils and things. So this is something self-defeating about this argument. And yeah, I'm not totally persuaded by this, but I'm still a little bit taken by this objection. Go on, Don, what do you reckon?
Yeah, so I've read Bagwell's paper, and I can summarize his objection myself. It says that Don's using the mathematics of evolutionary game theory to show that fundamental ideas in Darwin's theory, namely that there are physical organisms competing for physical resources in a physical space and time. He's using evolutionary game theory, which is supposed to model Darwin's theory, to actually show that fundamental ideas in Darwin's theory aren't correct. So now the argument goes, so now either the mathematics of evolutionary game theory is a faithful model of Darwin's ideas, or it's not. If it's not, then Hoffman shouldn't use it to try to disprove things about Darwin's theory. And if it is a faithful model, it would never give you any reason to dispute the fundamental things that Darwin's theory has assumed, physical objects in space-time. In either case, Don's in an unfortunate dialectical situation, right? So now my reply is quite simple. This fundamentally misunderstands the nature of scientific theories and what they do. Fundamental misunderstanding. Let's go to Einstein's theory of space-time, gravity. So Einstein's idea was that gravity is well, his big idea was that if I'm standing on a scale in an elevator, I'm weighing myself, and all of a sudden the cable is cut, and I'm in free fall, I would go to zero, or I'd weigh zero in space-time. And it took him several years, better part of a decade, to turn that idea into mathematics. But he finally, so he's thinking space-time is real, it's fundamental. And he writes down these mathematical equations. Now, later on, we find out from his equations and also from another equation he wrote down, E equals h nu, when you put those two together, you find out that his idea of space-time, first, number one, it has a beautiful scope to the theory. It's incredible, the scope of Einstein's general theory of relativity. It's one of the marvels of all time. But also the mathematics tells us the limits of that theory. Einstein's theory of space-time is great until you get to 10 to the minus 33 centimeters, and then his own mathematics tells you that those concepts are no longer coherent. So what happens is when we take a mathematical theory in science, in every single case, you will get not only the scope, but also the limits of the fundamental concepts that were mathematized. So what I'm doing is not some kind of ad hoc weird thing. This is the way science has to work. No theory is a theory of everything in science. Every theory makes certain assumptions. And you then make those assumptions precise with mathematics. And then if you've done it right, you find the scope, the explanatory scope of those assumptions, and you find the explanatory limits of those assumptions. And that's what makes science much better than non-mathematical ideas. With non-mathematical statements, it's hard to know where your theory stops. What are the limits of your theory? In science, with mathematics, we can say Einstein's ideas are great. At 10 to the minus 32 centimeters, they're great. At 10 to the minus 33 centimeters, nope, they're not. There's the scope and the limits. And so Bagwell's argument, if taken seriously, would be an argument against any of basically the way science actually progresses, where we take, so here's what we do in science. We take our ideas, our assumptions, we mathematize them, we find the scope, and we then look for the limits. And as soon as we find the limits, we go, hooray. Now let's find a deeper set of assumptions and new mathematics. And this is the way we pull ourselves up by the bootstraps. So Bagwell is sort of taken as a problem what is in fact the central strength of science.
Yeah. So two points on that. I'm not entirely convinced by that response.
Okay.
I mean, one thing is, yes, I totally agree with what you've just said about scientific progress. I share that sort of, the standard view in philosophy of science is that, in physics at least, it's important to distinguish, different sciences. In physics, we discover that the old theory only works in a certain domain of applicability, and then it breaks down, or we look to a broader theory. So maybe you gave a great example of general relativity, or maybe Newton's law of gravity works in a certain domain, but not outside of it. But Bagwell's this critique is not qualified in that way. It's not saying your argument fails in a certain domain of applicability. It's not qualified in that way. It's just saying
it fails itself.
Yeah, it's saying the argument cannot succeed because it's self-defeating, because the argument relies on the assumption that we evolved, but it also tells us that we wouldn't be able to know that we evolved. So it's self, and it's not saying that it's not qualified in the way we could, raise this problem with general relativity. Oh, it doesn't work in this domain of inquiry, domain of applicability. That's not what it's saying. It's just saying it doesn't work, period. So,
again, the way I think about it is that what I'm doing is I'm saying, let's assume for sake of argument, Darwin's theory of evolution by natural selection. Just like I did with Einstein. Let's assume, for sake of argument, Einstein's theory of gravity. We say if we assume that that's true, then we get the Einstein field equations, and then we can ask the question. Assuming that Einstein is right, we get these field equations, and then we can ask. So, are there any? Einstein assumed that space-time is fundamental. Can we use his mathematics to confirm his point of view? We find out. Well, it is not. It's not fundamental. It stops at 10 to the minus 33 centimeters. So now, are we being self-refuting by saying let's assume with Einstein that space-time is fundamental? We get the field equations. Now let's look at those equations and say, now what do those equations say about space-time? Well, they say it falls apart at 10 to the minus 33 centimeters. So now I'm using the same logic with evolution. I'm saying, okay, we have Darwin's theory of evolution, talks about organisms in space-time competing for resources. And now we have, John Maynard Smith has made evolutionary game theory. He's turned Darwin's ideas into mathematics. So now we can say, okay, we have this really good mathematical model. We can now ask, what are the scope and limits of the fundamental ideas? For example, should we believe that our perceptions are telling us the truth about objective reality or not? Well, it turns out we can answer that question using evolutionary game theory. For better or for worse, we may not like the answer, but the answer is that the probability is precisely zero that any sensory system has ever been shaped to see any true structures of objective reality. That's an implication of Maynard Smith's mathematization of Darwin. So that means that when I see physical objects in space-time, what I'm seeing almost surely is not the truth. And that means that the assumption that objects in space-time are the fundamental reality is almost surely not the truth on Darwin's own theory. Just as with Einstein's case, it's we start with Einstein assuming that space-time is fundamental, and then we use his own mathematics to say it can't be because it falls apart at 10 to the minus 33 centimeters. Same logic. So, but I'm pointing out again that this happens not just in these two cases. This happens in every good, precise scientific theory. We will always find the limits of those concepts. See, when we have a set of concepts, they will always have a limit, and we're trying to find in science what the limits of those concepts are.
But what is the analog in your argument of domain of applicability, if that's the right terminology? That the problem, that you're identifying that this limitation with Einstein's theory, that it breaks down in a certain domain, but it still works in a certain domain, but it breaks down in this other domain. But this objection, as I say, there's nothing analogous to that. It's just saying, if your argument works, we don't know we evolved, so your argument doesn't work. So there's no analog of the domain of applicability. Maybe the objection fails for reasons I haven't thought of yet, but if the objection works, it doesn't say your argument, we can still use evolution in this limited domain. It just says the argument doesn't work. I don't know, What's the analog of domain of applicability here?
Well, in Einstein's case, the fact comes out that space-time isn't fundamental. So Darwin's theory is not fundamental, but so neither is Einstein's theory is fundamental. What we can do then is ask, is there a deeper theory?
But it still works in a limited domain of applicability.
Oh, absolutely.
What's the analog of the domain of applicability in this evolutionary argument?
Oh, well, for all practical purposes, for example, in my book, The Case Against Reality, I spend half of the book exploring the power of Darwin's theory. I use it with companies to help them sell products and make genes that make you look better and so forth. I use Darwin's theory in great detail to actually do practical things. I think that is a wonderful theory inside space-time. Just like Einstein's theory is a wonderful theory inside space-time. Within the framework of space-time, Darwin's theory works wonderfully. And so does Einstein.
But this argument isn't saying it's self-defeating unless you're in the domain of space-time or something. It's saying it's self-defeating. It doesn't. The argument doesn't work, because if the argument works, we don't know we evolved, so the argument doesn't work. If it works, it means the whole thing just. It means the argument doesn't work. Period. I don't know. I can't. I don't know. I'm repeating myself. Well, can I? In case I'm repeating myself, can I raise a slightly different way of thinking about it? Yeah. Natural selection is a very different scientific theory to theories in physics. And I don't agree with Richard Dawkins on a lot of things, but I like him on evolution. And I agree with Dawkins that we need natural selection to explain the apparent design, right? And I know it's slightly complicated, Don, because you don't necessarily believe in the physical world, but you believe in our conscious minds, and I think our conscious minds exhibit apparent design. The way they're functioning is so structured and coherent and logical, and we have the capacity to reason. There needs an explanation of where that apparent design comes from. Natural selection provides it. So I think we need the theory of evolution by natural selection to be true. Whereas, if you seem to have an argument that we can't know it to be true. It can't be true because if it's So I think we need it to be.
Okay, so I can say what the next step is in my own way of thinking about things. So, and then you'll see why I'm still maintaining that this is not a problem. So, we have this Markovian dynamics of conscious agents outside of space-time, and it turns out when you look at this Markovian dynamics, the entropy in the dynamics does not need to increase. It's easy for us to write down dynamical system of conscious agents in which the entropy is not increasing. So there's no arrow of time in terms of an entropic arrow of time in these dynamics. But it's a theorem, a very simple theorem, that if you take a projection of this dynamical system that loses information, say using conditional probability, so you get a new dynamical system which is a projection of the deeper dynamical system that has no arrow of time. The new projected system will necessarily have an arrow of time. The entropy will increase because of the loss of information. So the idea is then that the arrow of time that you experience in this projected dynamics is not an insight into the true nature of the deeper dynamics. It's entirely an artifact of the projection process. Now to the evolution. What is the fundamental limited resource in evolution? It's time. If you don't get food in time, you die. If you don't mate in time, you don't reproduce. If you don't get water in time, you die. What I'm saying is, if we can have a dynamical system of consciousness outside of space-time that has no arrow of time. We take a projection by a conditional probability, and we get a new dynamical system inside space-time in which there is an arrow of time, and which now there appears to be limited resources and organisms fighting in time, and surviving, reproducing in time. And it turns out that all of that is an artifact of loss of information and projection from a deeper dynamical system in which there is no arrow of time. So what we would get then is, and this is how science works, I would find a new framework in which the arrow of time doesn't exist. There are no limited resources. There is no competition. But when you take a projection of it, you get Darwin's theory of evolution by natural selection precisely. You get evolutionary game theory precisely in that special domain of projection. So then we would have, so then we would explain why Darwin's theory was so successful in its domain, and why we could use Darwin's theory itself to predict that it would not be ultimately successful because it had limited concepts. So this is, again, I'm trying to show how science works. So ultimately, we take our theories. Every theory will have its assumptions. They necessarily, I make a bald statement. There is no scientific theory that will ever be published that does not have a limit. And its own mathematics better tell you the limit, or it's not a good theory. That's the way science works. And when you do that, then you get a deeper theory and explain why, for example, why evolution seems to be so powerful in this domain, and where the theory comes from, and how it's an artifact of a deeper theory.
So now you seem to be saying that, okay, natural selection is true, but it's not fundamental. But that your argument from Fitness Beats Truth is not an argument that, evolution's not part of the fundamental story, or it's only in the domain of space-time. Also, it's saying, given that our senses evolved, we can't trust them to tell us about reality. But if we can't trust them to tell us about reality, we don't know we evolved. Period. We don't know we evolved. It's not just we don't know evolution is true in some deep fundamental sense, and there really is space and time out there. No, if your argument works, we do not know we evolved. Period. But if we don't know we evolved, then the argument doesn't work, and so it's self-defeating, but also we can't explain the apparent design in our conscious minds. I think evolution, so that's the problem. I think you seem to be interpreting your own argument in a way that is not, it doesn't seem to me accurate, because you seem to be interpreting the argument to say, like, we didn't evolve in such a way that space and time. Yeah, I'm repeating myself, so I'll stop.
Can I see if I understand it correctly, and then you all can correct?
Sure.
So Einstein's theory of gravity doesn't say anything about the Planck length or not being able to go to it. Only if you combine Einstein's with quantum mechanics do you get this limit of, general relativity is consistent.
With his theory of the photoelectric effect, if you put in E equals h nu, then you get it.
Yeah, though that's not GR. That's GR in combination with quantum mechanics.
Right.
Okay.
You do get black holes out of GR, though.
Sure. So the point is that, look, in a theory like, let's say, GR, or whichever theory, it would say you can't exit through all of these doors. There are 300 doors. Maybe there are 10 of them which you can't exit. So it's showing some limits. Those are the scientific theories that point out their own limits. But Philip, it sounds like you're saying Don's theory is akin to A implies B implies not A, which is different.
Yeah, which is not saying the theory doesn't work.
Like inherently contradictory as a whole.
Yeah.
So is that what you're saying? So it's different than pointing out that there's some doors we can't go through.
Exactly. That's a good way of putting it, yeah.
Okay, so Don, then your response to that.
So I would reply that every scientific theory is not the truth. There is no scientific theory which is the truth. Every scientific theory says, grant me these assumptions, I will then explain this range of phenomena. But scientific theories cannot be the truth. They can only be projections of the truth. And so the question is, we take our assumptions of our theories, we find out the scope of that projection and the limits of that projection. But there's no such thing as, so when I say I like evolution by natural selection, I wrote half of my book on it. It's a wonderful projection and it's a useful theory and it's not deeply true. And Einstein's theory of space-time is a wonderful theory and it's not deeply true. We're going to let go of space-time altogether. We will find new frameworks entirely. And this is the way science, so I'm saying this is the way, so there is no theory of everything. My big point here is there is no theory of everything. There cannot be. And therefore, every theory will ultimately be false. It can be a good projection of whatever the truth is. It can be a useful projection, but it's not the truth. And so all we can do is say, why does evolution work? Well, it's a good projection. And inside space-time, there is no better theory about our origins and so forth. But as soon as we step outside of space-time, then all of a sudden we don't even need the notion of limited resources. But we can see how limited resources arise as an artifact of projection. So I'm saying that if we want to say that I've caught myself in a terrible, self-contradiction, this is what's going to happen with every single scientific theory, and in the same way that I'm doing it with evolution. It has to, because they're not true.
It's like there's it's true or it's deeply true. I mean, I think that gets a precise meaning in terms of these theories in physics, where we can say, well, it's true in a domain of applicability, but it's not true per se across the board. I guess I struggle to see how we carry that over to natural selection. Say, in what sense is it true but not true? I mean, I think I think it needs to be true, but yeah. And again, the argument is not just that it's not true in a certain domain of inquiry. Yeah.
Okay, how about this? Did we evolve? Yes or no? And then I want to hear both of your answers to that.
Okay, great.
I would say yes. Yeah, I mean, I take the standard scientific view of this. Yeah.
Don.
And I would say that when we look at reality through a particular space-time headset, it looks like we evolved. But the evolution framework takes time as a fundamental entity. I don't think time is a fundamental entity. I think time is an artifact. It takes objects that in space-time as fundamental, that it takes space-time as fundamental. I think space-time doesn't even work beyond 10 to the minus 33 centimeters.
Speaking of Daniel Dennett, he said that the fundamental unit of natural selection is one that undergoes replication, variation, and selection. Now, this selection mechanism can be abstract. It doesn't just have to be with respect to time. It can be any resource. So, given that, does evolution or natural selection indeed reference time? Or would you say, yeah, there's an implicit time parameter because of steps?
Well, when you go more abstract in evolutionary game theory, you still have a time parameter, right? You have, for example, the successive generations gives you essentially a time parameter.
I see.
So I'm saying that that this is a ubiquitous feature about how science works. Each theory will have its own set of concepts, like organisms competing in time for resources and dying and having reproduction. That's that, and it will have its domain of applicability. And by the way, most theories we come up with are just not have no domain of applicability. They're just useless. We have these rare theories that really are wonderful in a domain, like evolution by natural selection. It's beautiful in its domain, but it's not deeply true. I think that time isn't deeply true. And so the foundational concept of evolution in time is fundamentally flawed.
I've got a slightly... Oh, sorry.
Just one. What's beautiful about the theory of evolution is that its own mathematics allows you to predict its own limits. That and that's not self-contradiction. That is the glory of scientific theories, that the theories predict their demise.
I've got a slightly different way of trying to make the point. I mean, okay, so you don't think evolution is true in some deep sense, but you think it's true in some more lightweight
Projection.
sense, in some domain of applicability. Okay, and I'm struggling to articulate that difference. That's what. But just take that for granted. How do you know we evolved in that more lightweight sense? How do you know? Agreeing, we're talking about that more lightweight sense. How do you know we evolved?
Oh, well, I would say that from this deeper point of view, we know that we didn't, but it's a useful framework within
Right.
space-time. It's a very useful
it's-
framework to think about it as evolution.
It's true in some sense, right? It's true in this projection or whatever.
Well, it's
true-
like
it's
if
true.
I'm playing Grand Theft Auto in virtual reality.
Oh,
Right,
great
and I
point.
could say-
Trailer just got dropped for Grand Theft Auto 6. Oh my gosh. Fantastic.
Right. So if I say, there's some supercomputer I'm interacting with, and all I see is Grand Theft Auto, right? And so I'm racing in my car. Now, I can say I'm racing in a red Ferrari, and my car can go faster than your green Mustang, and so forth. And those may be true statements in the game, but ultimately they're only true of the game. And if I say, but I'm going to go now to a bigger framework, I'm going to look at outside of the Grand Theft Auto world. What is that? Well, it's some supercomputer. Well, now is it really true that there's a red Ferrari and a green Mustang? Well, no. If you actually look inside the supercomputer, you won't find anything like red Ferraris or green Mustangs anywhere inside there. You'll find bits and so forth. But within the context of the headset, sure, that's the best theory, and that's what you should do. But a good theory of Grand Theft Auto would actually tell you, there's more to life than Grand Theft Auto. It won't tell you that there's a supercomputer, but it will tell you that Grand Theft Auto can't be the whole story. And that's all I'm doing with evolution. It's not the whole story.
I'm trying to focus on that from within the Grand Theft Auto world, from within the headset, there's got to be some sense in which the creationist is wrong, right? That the Earth is 4,000 years old, that we didn't evolve by natural selection. There's some sense in which the creationist is wrong. Okay, it's not a deep sense. My question is, how do you know? How do we know that the creationist is wrong and the Darwinian is right in that headset relative context? And surely you've got to say, well, we used our sensors. We used our sensors to find out that the creationist is wrong. I don't think you can say that if your argument works, because if your argument works, our sensors evolve for truth, not fitness, not truth. We don't know. We don't know if the creationist is right or wrong. That's the worry.
This is the key point. We don't need to believe any of our theories, right? I'm a scientist. I create theories and I evaluate theories. I don't. So all I do is I take the theories, and I'm not stuck inside my theories. I'm the one that creates them and evaluates them. I just look at evolution by natural selection and say, here's the mathematics. The mathematics entails the probability is zero that I have any true perceptions. That's what that theory says. Now, what I believe about my senses is something different. I may still say, I don't believe that implication of evolution. It's nevertheless an implication of evolution. So I can say that I love evolution. It has all this power, but my senses are not limited. For example, I might say that but the mathematics of evolutionary game theory says that they are limited. Aha. That's what that theory entails. Maybe I want to say that there's a point where I disagree with evolutionary theory. I love it for all this other stuff. But on the other hand, I may say, maybe it's when it says we shouldn't take our perceptions literally, maybe we should interpret that as pointing to this as just a headset. And if that's the case, then I would say, yeah, wow, evolution actually pointed to space-time as just a headset, and don't take it literally. In which case I would give it a big thumbs up and say, but it doesn't tell us what's next, right? Just like Einstein doesn't tell us what's outside space-time. The new physicists are having to make broad and bold leaps outside of space-time. You have to really go out there. But what you do is you write down your new ideas, and of course, most of them are not even worth it. Most of them are wrong, but every once in a while you get a good idea, and then what you have to do is show that it projects back into space-time and gives you answers that we can test inside space-time. So whatever we come up with outside space-time better project into space-time, and it better give us Einstein, and it better give us evolution by natural selection as the projection. If my theory of so here's how I put it. If my theory of conscious agents outside space-time, when I project it into space-time, doesn't give me physics, Einstein's physics, quantum theory, and it doesn't give me evolution by natural selection as the projection, then I'm wrong. So evolution is a absolute acid test on my deeper theory.
Right, I'm gonna
that's how science works.
One more time, and then I'm gonna
Sure.
give up because probably we're not gonna convince each other. That very thing you said then, that my theory had better give me natural selection as a projection. That's a constraint. It better give me that. How do you know it had better give you that? Through using your senses, through using your senses has obviously given you empirical reason to think your theory had better give you that, as opposed to what the creationist would constrain their theory with. And I think if your fitness bits truth argument works, you can't trust your senses. And so, yeah. Anyway, go on. That's the last. I'm going to
see. I don't believe evolution. Evolution says that we shouldn't.
No.
That our senses,
but you did. I was
need to believe
focusing on the specific claim you just made.
Right. So evolution. So all I'm doing as a scientist is I'm just telling you what this theory entails, and I don't have to believe it. I can say it works over here, and I don't believe this part of it. It's just so I'm not caught in my theory. I'm an evaluator of the theory, and the argument, by the way, is actually quite simple. There are fitness payoff functions, right? Fitness payoff functions are functions that go from whatever the world is, the state of the world, into the payoffs, say from 0 to 100. And you can ask a simple technical question: what is the probability that a generically chosen payoff function would be a homomorphism of any structure in objective reality, like a total order, a partial order, a metric, whatever it might be, a topology? And in every case, the answer is precisely 0, because you would have to, for a fitness function to be a homomorphism, it has to satisfy certain equations. Almost no randomly chosen fitness payoff function will satisfy those equations. It's just that simple. So all I have to do is say, look, evolution by natural selection is an incredibly powerful theory, but it entails almost surely, with probability 1, that no sensory system has ever evolved to see the truth. Now, once I've taken that from evolutionary theory, I can say, well, what could that mean? Well, maybe it can mean that my senses are just a headset, in which case I could be looking beyond this and ask for what's beyond my space-time headset. Or I could just refuse to believe evolutionary theory on that point. I myself think evolution might be right. I don't see the truth, and this is just a headset. So that's how I go with it. I say, I love evolutionary theory. It says you're not seeing the truth. I believe it. We're not seeing the truth. It doesn't mean that I'm caught in evolution, because I have this deeper theory that shows that evolution is an artifact, that even time itself is not an insight into the deeper realm. It's an artifact.
So, Philip, why can't Don be saying that Darwinian evolution is some approximation? It's not exactly correct. There's neo-Darwinism and there's EES. So there are various agglomerations or pieces added to Darwinism afterward. In other words, some biologists would agree that the way we traditionally view natural selection, isn't the only mechanism by which we evolve. Okay, so why can't Don say, hey, look, evolution didn't happen in the exact way that we thought. If it did, then it would lead to a contradiction. It could happen in some approximate way, and there could be some underlying mechanisms that are slightly nuanced that produce the wonderful variety we see. And I also don't know, Don, if that's what you're saying. I don't mean to speak for you, by the way. I'm just saying, why can't that be an argument?
Well, so I suppose in the domain in which we're talking about our senses and our conscious experience and the apparent design that seems to be in our conscious experience, we need to appeal. I think I agree with Richard Dawkins. We need to appeal to the truth of natural selection in order to explain that apparent design. But if this argument works, then we can't do that. We can't, because we can't trust our senses to find out that empirical information that we did evolve through natural selection. So the whole thing doesn't get off the ground.
Don, do you have another analogy other than the supercomputer? Because the computer itself implies computation. Computation implies step by step, in which case you can have time. If we're going to abstract time to say that successive generations can also be time, then this supercomputer that we could potentially be part of could also have time in the computational steps. So do you have another analogy?
Well, the example that's not an analogy, but is in fact what we're working on, is this Markovian dynamics, in which there is no arrow of time. So this is a literal mathematical system that we're working on right now. We published a paper called Fusion. People want to see this.
Right.
Came out in January, called Fusions of Consciousness, and we actually at the end of the paper raise this issue. We point out that our dynamical systems don't need to have an arrow of time, but then we give the proof. We actually have a 3 or 4 line proof that any projection will give you an arrow of time from our system. So what we would love to do is to come up with a dynamical system of conscious agents that projects into space-time. And that's the paper I'm working on right now. That's exactly what I'm working on today, is that mathematical projection. We're making really good progress. And my intent is to show, when we get that projection, that we can get evolution by natural selection in our projected version. So we'll have a theory in which there are no limited resources, there are no organisms competing, no nature red in tooth and claw. But when you take this projection and you lose information, it looks like nature red in tooth and claw. It looks like there's an arrow of time, and all of that is an artifact of the projection. And I'm saying this, there's nothing special about this. This is the way science works. We go from Newton to Einstein. We get Newton as a special case, but there are things Newton can't do. And there's things that Einstein can explain why you can't do them, but you can do them on Einstein. And then you see Newton as a projection. When C goes to infinity, you get Newton as a projection. That's what I'll get Darwin, all of evolution by natural selection, as a projection when I let go of space-time.
Can I make one quick physics point? I would say it's the opposite. I would say that it's with Einstein that you have the limitations. In fact, with Newton, you can do anything, because you can go as fast as you like. There are no black holes. It's just Newton can't explain everything, which is different
That's
than
what
Newton
I mean.
can't do
You
everything.
can't, by do, I meant explain. Like, you're absolutely right.
Yeah.
By do, I meant explain.
I mean, I suppose I could put it as a sort of dilemma. You know, if we're just saying natural selection is not fundamental, you know, that it's just true in some non-fundamental story of reality, well, then I don't think that gets around the Don's argument, because Don's argument isn't saying, you know, appealing to what's self-defeating or not in some non-fundamental story. But if you say, no, it's just not really true, it's just not really true, well, then I'm worried, because we need it to be true, you know, to explain apparent design. So either way, there's something going wrong here, I think. That's yeah. Anyway, maybe we should talk about something else.
I don't know if we'll make much progress on this one point, and I'm sure there are at least 2 more points that you all could talk about. So I'm going to try my best to rephrase it, actually paraphrase John Vervaeke, and I want to see if, Philip, if you agree with this, and then we'll see if we can make headway here. But if not, then we can move on to something else. So John said, and it was either to you, Don, or John said this to Bernardo Kastrup. John Vervaeke said, if the level from which we do our science is illusory, then how does that not undermine all the claims of what we're making from that level? So in other words, if we're claiming science is somehow illusory, but yet we're using science to make that claim, how does that not undermine itself? So is that what you're saying, Philip, or no?
It sounds related. Yeah, I mean, I suppose that, again, that's why I suppose my position is a middle way between physicalism and idealism. I'm a scientific realist, maybe a bit of a structural realist rather than anything more hardcore.
Are you a reductionist?
Yeah,
are you both reductionists?
I'm less and less reductionist as I get older, actually. I started off in my academic book, Consciousness and Fundamental Reality, really trying to be very reductionist. And there are certain great panpsychist philosophers like Luke Roelofs who try to be very reductionist. And but actually, the more I've talked to neuroscientists and some condensed matter physicists as well, I just think... I sort of think the reductionist idea is a bit of a dogma that we've, we don't know anywhere near enough about the brain to know whether everything that goes on in there is totally reducible to underlying chemistry and physics. And you've got interesting views like the assembly theory, the very kind of non-reductionist theory, or Kevin Mitchell in neuroscience arguing for sort of strong emergentism about consciousness. So yeah, I'm less and less convinced that we need a very reductionist story. But still, I'm a hardcore realist about physical reality as physicists describe it to us. It's there when we don't look at it, but it's that's just mathematical structure. So we need something to fill out that mathematical structure. That's where consciousness comes in. But yeah, I'm not so persuaded that we need to think that everything that goes on in the brain or in living systems is just a product of the basic laws of physics. I think that's kind of a dogma that fits with the zeitgeist of the moment, but it's not actually something empirically proven.
So, Don, would you characterize yourself as a reductionist? And by reductionism, I mean that there are individual components that somehow in their interaction give rise to all the complexity we see. And these components, these are constituent phenomenon that could be something simple like cellular automata, or Rubik's cubes, or emoticons at the fundament, and somehow these underived components spawn everything else.
No. So by reductionism, I would mean that as you go to smaller and smaller scales of space-time, you find more and more fundamental entities and more fundamental laws governing those entities. That's what I take reductionism to be the claim. And I think that in certain cases, that's been very useful, like in thermodynamics and so forth. It's that kind of approach has been very useful. But again, many high-energy theoretical physicists are saying that reductionism is doomed because the Planck scale is the end of the whole story for smaller and smaller scales. And if you try to go to even smaller scales, what happens is you get a reversal. Instead of going to smaller scales, you get bigger and bigger black holes. So you actually start so you get a reversal of things. So many high-energy theoretical physicists are now saying that reductionism is doomed because space-time is doomed, and I agree. So I'm not a reductionist, and it's been useful in certain aspects of science, but it's not deeply true.
What if by reductionism someone doesn't mean anything to do with space-time, but just that there are some more simple elements, whether it's cellular automata or Rubik's cubes, that are at the fundament and that breed life when they interact in some way to give rise to all the complexity we see. And that if you were to break down, quote unquote, break down, whether in scale, like with microscopes, or whether in some other scale, like time or something else, that everything we see here can be predicted from these tiny elements, these underived elements. So what if that's what is meant by reductionism? Are you both reductionists then? Do you think there's something more than that?
I had a recent article in Scientific American people could look up. I think there's a good argument, and this is something I explore in the consciousness chapter of the book, which is probably the most challenging chapter of the book. It comes with a warning at the start, but I think I hope some of the more original bits of the book. I think there's a good challenge to the reductionism, precisely as you just defined it, Kurt. From the need, we come back to evolution, from the need to make sense of the evolution of biological consciousness. And the thought is that natural selection only cares about behavior, right? Because it's only behavior that matters for survival. But with the rapid progress in robotics and AI, I think it's become apparent that you can have incredibly complex information processing and behavioral functioning without any kind of subjective experience at all. So then this gives rise to the question, why didn't natural selection make survival mechanisms, very complicated mechanisms that can mechanically track features of their environments and initiate highly survival conducive behavior, but without having any kind of subjective experience at all? I think this is a really deep challenge. Why did consciousness evolve? Given that complicated mechanisms without consciousness could in principle have survived just as well. So I think there's a really deep, neglected puzzle here. And I think part of the solution has to be that consciousness makes a behavioral difference, that systems with unified consciousness and conscious understanding of the world around them, that this opens up radically new forms of behavior that are much more conducive to survival than just the forms of mechanistic behavior you just get from, building up a mechanism from the laws of physics. So that's a sort of argument I try to press from the need to make sense of the evolution of consciousness against the reductionist paradigm.
Thon.
Well, so my framework is a little bit different on this point. So I would say that space-time is just, and the laws of physics are just one particular headset that consciousness can use, one of countless many, and there's nothing particularly interesting about space-time or special about it. It's what's interesting about it is probably one of the more trivial data structures that consciousness can use, not one of the more deep structures. I can only imagine three-dimensional objects. I can't even imagine a four-dimensional or a five-dimensional object. And that's a real impediment in a lot of the research I'm doing. I need to imagine, objects that are of much higher dimension. I can't do it. I only have 3 kinds of color receptors. Mantis shrimps have 10 or 11 or whatever. In many ways, I feel like my space-time headset is I got a really cheap version of it, and the laws of physics are really, put it this way, we're not seeing the true causal structure of anything. In Grand Theft Auto, I have the appearance of causality. I turn my steering wheel, my car goes, all this, it goes down the streets and so forth. But the appearance of cause and effect in space-time, I would claim, is utterly an illusion. It's a useful illusion, but it's utterly an illusion, the same illusion as in a VR game. It looks like the steering wheel turning is causing my car to turn. Nothing of the sort is happening. The steering wheel has no causal powers, none. And there are no causal powers inside space-time whatsoever. So that's the. So you can see my framework is entirely different. But what I have to do is then show, well, who am I then that's doing this? I'm not an object in space-time. I'm not a small consciousness inside space-time, and I didn't ultimately evolve inside space-time. Space-time, I'm not in space-time. Space-time is in me. Space-time is a little data structure in me, and it's not the only one that I could possibly use. So it's a complete reversal of the whole picture.
Mm-hmm. What I meant by reductionism doesn't have to have causation. I just mean that you can understand the whole by analyzing its constituent parts.
Okay.
If that's the definition of reductionism, do you still subscribe to it or you don't subscribe to it?
Well, again, if you think about the headset approach, ultimately, when you look at smaller and smaller scales inside the headset or parts, you get down to pixels. And in some sense, you don't really explain anything. My steering wheel can't be explained by the pixels out of which it's made, right? This is just not going to explain that. So ultimately, my feeling about scientific theories is that every scientific theory ultimately is only a projection of the truth. It's never the truth. It's a very limit. So no scientific theory can ever be a theory of everything, and every scientific theory will automatically have its necessary limits. And ultimately, my feeling is that every scientific theory, my own included, scratch probability zero depths of reality. In other words, reality, whatever it is, will infinitely transcend any scientific theory's attempts to explain it. And that's just the way that's just the way it is. So there will never be a theory of everything. And the simple argument for that is, look, every scientific theory makes assumptions. Those assumptions are the miracles of the theory, right? You're not explaining those assumptions, you're assuming them. You can say, well, I can get you a deeper theory that explains those assumptions. You can. Your deeper theory will have its own assumptions. And this goes on ad infinitum. Ad infinitum. And that means that we're infinitely far. Right now, we're infinitely far from a theory of everything, and we will always be infinitely far from a theory of everything. And that includes Hoffman's theory, is infinitely far from a theory of everything. So deep humility is required at every step in our scientific theory building. Very, very deep humility. And it raises the question, who am I? Who am I that I transcend space-time? Space-time is a little data structure in me. I'm not a little object in space-time. Space-time is a little data structure that I use, and it's one of many that I could use. Who am I that is doing this? It raises a very, very deep question. In that sense, I take the idea that consciousness is fundamental very, very seriously. That it transcends space-time completely. Space-time is trivial. It's a non-entity compared to the depth of consciousness. It's a complete non-entity in terms of its complexity. We transcend it. Whatever we are completely transcends it. And when we die, we'll drop that headset and we'll find out who we are.
Is it time to talk about the meaning of life? I think it's getting deep.
The other part of your book, right? The other part of your book.
No, go on.
What is the meaning of life, Philip?
Yeah. So, but most of this book is just a sort of cold-blooded scientific and philosophical argument for cosmic purpose, arguing that there is reason to take seriously this idea of goal-directedness at the fundamental level of reality. Weird as it sounds, I just think that's where the evidence is pointing to, and we have to face up to that. I annoy people on Twitter by suggesting that Bertrand Russell would have believed in cosmic purpose because he followed the evidence where it led, but it just wasn't there when he was alive. But so yeah, most of the argument is that just cold-blooded case for that. But I suppose in the first and last chapters, I'm thinking about the implications for human existence. And yeah, I don't want to be kind of too dogmatic about what is the single way of living a meaningful life. I suppose I'm interested in suggesting options that are maybe different from the familiar options of traditional religion on the one hand and secular atheism on the other. But yeah, overall, I think there's a defend a kind of middle way ground here, really. On the one hand, you get some religious philosophers like William Lane Craig who say, if there's no point to the universe, it's all pointless. We might as well just rape and kill each other. It's all totally pointless and meaningless. The other extreme, you get, the familiar secular atheist position that probably there isn't cosmic purpose, but if there is, it's totally irrelevant. We make our own meaning, whatever. So I try to defend a middle way that, yeah, you can have perfectly meaningful life without being a purpose to the universe, by pursuing kindness and creativity and knowledge and so on. But if there is a purpose to the whole of reality, then maybe there's a potential for our lives to be more meaningful. If you can contribute in some small way to the purposes of the whole of reality, that's huge. We want our lives to make a difference. That's about as big a difference as you could imagine making. So, yeah, and just finally, I suppose, just speaking for myself, I feel starting to live as a cosmic purposivist, this living in hope that there's a greater purpose to what's going on here.
A cosmic what?
Purposivist. Cosmic purposivist. Right?
I see.
Living in hope of a greater purpose to what's going on. I have found to be a deeply kind of meaningful form of living. I think most of all, it has brought me a deep sense of peace in some way. I was talking to my wife about this just this week. Because I guess I'm quite kind of career driven. I hope partly through pure motives, like I really believe in the things I'm arguing for and I want to persuade the world. Probably there's a bit of ego there as well, want to kind of make my mark or whatever. But I found that cosmic purposivism has made me less bothered about those things. Not because I don't think they're important, but because I'm conceiving of them as part of some much bigger thing that's going on that I'm inevitably just a tiny part of. And hence my task is just, to do the best I can to contribute to this much bigger thing going on. And conceiving of things in that way, I suppose, makes me less bothered about my own personal successes and failures and frees me up to enjoy life a little bit more, enjoy playing in the snow as I was with my family this weekend. Not that I wasn't happy before, but maybe but a deeper sense of happiness. So yeah, so I suppose I'm just trying to suggest options that aren't the familiar options for thinking about the meaning of life.
Okay. How do you argue that, by the way? So you just outlined some views, but how do you argue that those views are correct?
Well, that's I guess going back to the starting point. So part of it is the fine tuning of physics for life, which I think just in our standard Bayesian way of thinking about things just is evidence that there is some kind of goal directedness towards life in the very early stages of the universe. And I think we're sort of in denial about that because it just doesn't fit with how we've got used to thinking about science. As I said, there's I used to think the multiverse option was the obviously more plausible option for a long time. Cosmic purpose sounded very silly to me, but I've been persuaded that there's some dodgy reasoning going on in trying to explain fine-tuning in terms of the multiverse. I could talk about that if you want. Also the kind of arguments about making sense of the evolution of consciousness that we started talking about then. So it's those two things, I think, making sense of the emergence of conscious understanding, which I think belies our current scientific paradigm, and the fine-tuning of physics for life. Most people think, oh, well, God is the alternative, but I think there's a middle ground, a neglected middle ground here between the traditional atheist picture of a meaningless, purposeless universe and the traditional Western God, on the other hand.
Don, what is the meaning of life to you? And feel free to comment on anything that Philip has just said.
Well, first, on the point of agreement, I think that I believe in a version of purpose, of conscious purposiveness, whatever the word was. So I think it's not the standard physicalist framework that we're nature red in tooth and claw, and there's really no meaning and purpose, and it's pointless. I think that's just taking the headset literally when we shouldn't take the headset literally as the final word. My own view on purpose is, and comes with who I think we are. So I don't think I'm a 160-pound object in space-time. I think that space-time is a tiny data structure inside me and inside you. I think that I am and you are consciousness that transcends any scientific theory. That I am the deep reality and you are the deep reality of consciousness. You are that consciousness. And in fact, there's only one. So in fact, my view is that right now, consciousness in a Hoffman avatar, a Philip Goff avatar, and a Kurt avatar is talking to itself, the one infinite consciousness. And what it's doing is finding out about itself. In some sense, the infinite consciousness knows itself by knowing what it's not. It plunges itself into this little headset, loses itself, thinks it's a little object in space-time, and then slowly wakes up and realizes, no, I transcend this headset. And that's how it knows what it is, by knowing with countless headsets what it's not. So the purpose is, from my point of view, is consciousness is here to know itself by waking up to what it's not. And the fundamental thing that comes out of this is that, some religions say love your neighbor as yourself, but I'm saying your neighbor is yourself. And that is the foundation for true love, is to recognize that that's just me under a different avatar. Even my cat is me under a different avatar. And so from this point of view, the whole purpose of life is I'm this infinite consciousness that is finding out who I am. And it's a theorem that it'll never be done. It's a mathematical theorem that no system can ever truly know itself, because in the very act of knowing yourself, you build a model of yourself and you become more complicated. So now you have to get a new model of yourself with the more complicated model and so forth. So this is the one consciousness, the infinite consciousness, posing as a philosopher, as a scientist, and as a podcast interviewer, and learning about itself and waking up. And eventually it takes off this headset and tries on a less cheap headset than this one. and goes through the same process in a different way. So that's sort of my guess about what it is and what
Can
it's
I
about.
just add something to that? I mean, I guess it's another point in which I value Don's work and in which we're trying to do something similar, that I think there's a huge demographic, a huge proportion of the population that identify as spiritual but not religious. But in general, academics don't cater for that group. In academic philosophy, I would say most people are secular atheists. There's some really good quality philosophy of religion, but it tends to be very traditional Christians,
Correct.
few Jews. There's one very good Muslim philosopher of religion that's in the analytic tradition that's emerged recently. And then I think from that, we get this perception that spiritual but not religious is fluffy thinking and not very thought through. But I think that's just the contingent circumstances that, academics haven't put rigorous work into developing philosophically, scientifically supported options here. So this is one thing I'm trying to do with this book. And I've got a 3-year Templeton project on trying to work out if the universe is conscious, that's kind of related to this stuff, that funded this conference that Don came to, where I debated Sean Carroll on whether consciousness is fundamental. People can check out on YouTube if they're interested in. But yeah, so I think that's very exciting that this whole new, it's always been there to an extent, but is connecting up this whole new kind of academic area of trying to make rigorous sense of between traditional religion and secular atheism, and just expanding the debate is always really interesting and adds new challenges. Although I don't like this idea that we're all the same person. I guess I'm a little bit more Western in my thinking than Eastern on this regard. I sort of feel like the value of love and self-sacrifice, right, is that you're not me, and I'm still, sacrificing myself for someone that's not me, that's the other. And I find that's what's beautiful about love. And when it's like, oh no, it's just me, it's all me, that kind of depresses
Then it's
me a bit.
masturbation.
I don't know. Yeah, sex is just masturbation. I hadn't thought of it. That makes it even worse now you put it that way. But that's not an argument. That's not an argument. That's just a sort of primal ethical response.
Many of these claims come down to gut intuitions. So, Don, I'm curious about the neurons not existing, but the cat existing. So the cat is an avatar that has its own perspective. Then if we were to scale that down into the perspective of a neuron, then does a neuron still technically exist if you're not there because the neuron has its own headset? Or even, let's just say the cat.
Well, yeah, or the cat, right? So ultimately, it's consciousness looking at itself through a headset, and so sometimes it sees itself. So what does a headset do? A headset dumbs things down, right? That's what a headset does. It deletes lots of information. So from this point of view, I should be very, very clear. The distinction that we make between living and non-living things is not principled. And the distinction between conscious and unconscious objects is not a principled distinction, in my point of view. So right now I'm looking at you guys on a video screen, and I see pixels of Kurt's face and Philip's face and so forth. But I also see pixels of the background, like of the walls and so forth. Now, some of the pixels are giving me insight about Philip's and Kurt's consciousness, and others are giving me nothing on the wall. Now, do I want to say that certain pixels, like, are conscious? These are the conscious pixels, and those are the unconscious pixels? No, that's dumb. Pixels are just pixels. From this point of view, in which space-time is just a headset, the distinction we make between living things like cats and non-living things like rocks is entirely an artifact of the limits of our headset. I'm always interacting with consciousness, always. And I'm always interacting with an equally complicated one infinite consciousness. I'm always interacting with that. So there's not like stupid consciousnesses. No, I'm always interacting with the one infinite consciousness. But my interface, because it's an interface, dumbs things down. So when I'm interacting with the cat, I am this one consciousness interacting with itself through a headset and looking at itself. So I'm getting a cat image of myself or a bacterium image of myself, or whatever it might be. These are all perspectives of myself. They're just perspectives. They're not the truth. but I'm always interacting with the one infinite consciousness. Now, in the paper that we're about to write on this, we actually have an idea about how to talk about the one. Right. We found a partial order on consciousnesses. So it's a mathematical structure. It's a non-Boolean order on consciousnesses. It's a completely mathematically rigorous thing. And so it turns out it's non-Boolean, and there's no ultimate top to the one. So when I talk about the one, I'm not talking, typically we think there's some guy at the top or something like that. No, this is, the mathematics of this is far more complicated. It's a completely non-Boolean structure. And so when I talk about the one, I haven't wrapped my head around conceptually what that could possibly be. It's too complicated. Also, to wrap your head around it, you'd have to go all the way up Cantor's hierarchy and beyond Cantor's hierarchy. So this is a partial order that goes all the way up Cantor's hierarchy and so forth. So when I talk about the one, it's not a trivial thing. There's the mathematics is complicated, and I'm sure this complicated mathematics is trivial compared to the structure of the one. So whatever this one is, it's truly impressive, and it's looking at itself through cats and rocks and so forth. But I'll just repeat again: the distinction between living and non-living is not principled. There's no deep distinction there, and the distinction between conscious and unconscious is not principled. All of them are artifacts of the limitations of our headset, and nothing deeper than that.
I think we're probably coming back to some agreement again with the distinction between living and non-living, conscious and non-conscious. I'd like to ask Don, actually, I don't know whether we're running out of time, what you think about the fine-tuning of physics for life. But before I do that, actually, Kurt, would it be all right to say, what's wrong with the multiverse? Would that be permissible?
Sure.
Because, no, I'm really excited about this, actually, because this has been an argument that's been in the academic journals about probability for decades, since 1982. But in a typical case of academics talking to themselves, nobody knows about it outside of academic philosophy, despite huge interest in fine-tuning and some physicists arguing for the multiverse, some theists arguing for God, and so on. So I'm really excited to get it out to a broader audience. So yeah, the basic claim is that it's the inference from fine-tuning to a multiverse commits the inverse gambler's fallacy, right? So suppose Don and I go to a casino tonight, and we walk in, and the first thing, we go into a small room and we see someone. There's just one guy having this incredible run of luck at roulette. It's just winning and winning and winning, and and I turn to Don and say, "Wow, the casino must be full tonight." And Don turns to me and says, "What are you talking about? We've just seen this one guy." And I say, "Well, if there are tens of thousands of people playing roulette in the casino, then it's not so surprising that someone's going to have an incredible run of luck." And that's just what we've observed, someone having an incredible run of luck. Now, everyone agrees that's a fallacy, right? Our observational evidence is just this one individual having an incredible run of luck. And no matter how many people there are playing roulette in other rooms in the casino, it has no bearing on the likelihood of this one particular person we've observed. It's related to the more familiar gambler's fallacy. You think, "Oh, I've had a terrible luck all night. I'm bound to win big now." So everyone agrees that's a fallacy, but it looks, to my mind, indiscernible to the reasoning of the multiverse theorist, at least if they're arguing from fine-tuning. You look around and think, "Oh my God, the numbers in physics are just right for life. There must be loads of other universes with terrible numbers," right? Well, our observational evidence is just this one universe we've observed. No matter how many other universes there are, has no bearing on the likelihood of this one universe we've observed getting the right numbers. It's just like postulating other people playing other people playing roulette elsewhere in the casino to explain the one individual we've observed. Now, there are all sorts of, there's the anthropic principle people bring up. There's the scientific case for the multiverse. Well, actually, I'm also excited that even though this particular objection to the multiverse has been discussed for decades in the journals, no one's connected it to the actual scientific discussion based in inflationary cosmology of the multiverse. So that's what I try to do in the book. So I think Even once you take into account the anthropic principle and the scientific evidence for eternal inflation and so on, I still think the basic problem survives, that it's just fallacious, demonstrably fallacious reasoning. And so we're stuck with cosmic purpose.
So what if someone says, well, it's not a fallacy because in that example with observing the person winning over and over, you could potentially see other people not winning. Whereas in the case of the fine-tuning of the universe, a better analogy would be that we're in the office where people come in to get their check for winning the lottery, and we keep seeing people there, and we're like, oh, everyone's winning the lottery. Yeah, but you're only able to see the people who are winning the lottery. So that would be the better analogy.
Good. Yes. So that's kind of appealing to the anthropic principle. Well, two things. I mean, one, we could just add to the analogy, right? Suppose there's a sniper at the back of the room waiting to blow our brains out as we walk in, if the first person isn't winning big, right? And so we create a kind of artificial selection effect. So now it's just like real world fine tuning, right? In that scenario, the only thing we were able to observe is someone winning big, but that still doesn't mean the fallacy goes away. But at a deeper level, I think, and this is what I go into in the book, we know what's going on behind this fallacy. It's rooted in a very important principle in probabilistic reasoning called the requirement of total evidence, which is the principle that you're obliged to always work with the most specific evidence you have. So suppose, Don's on trial for murder, and the prosecution says to the jury, Don always carries a knife around with him. When the reality of the situation is Don always carries a butter knife around with him. Right? Now, the prosecution has thereby misled the jury, but they haven't lied. They've misled them by not giving the most specific information we have, which is not just that he carries a knife, but that he carries specifically a butter knife. So this is a very important, well-accepted principle. This is what the multiverse theorist violates, because they construe the evidence of fine-tuning as some universe is fine-tuned, right? And then that's made more likely by a multiverse. But we have more specific evidence than that, namely that this universe is fine-tuned. Just like in the casino case, our more specific evidence is this person has played well. Now, we're obliged by this principle to work with that more specific evidence. And once we do, then a multiverse is not going to explain fine-tuning. I mean, maybe I could I've talked a lot already, but the case you give is Roger White, who wrote the classic paper on this in the year 2000, it's what he calls a converse selection effect, right? The example you gave where we're in the office, where if someone plays big, someone plays well, we're going to observe them, right? So that's like, in with the real world selection effect, that the real world selection effect is that if we exist, the universe must be fine-tuned. But it's not the other way around. It's not if there's a fine-tuned universe, we're going to be in it. That's the converse selection effect. So White makes that clear with a sort of sci-fi analogy. Imagine we were once disembodied spirits floating through the multiverse, looking for a fine-tuned universe. And once we find a fine-tuned universe, we go into it. In that case, there'll be a converse selection effect. Right? Not only if we exist, then the universe is fine-tuned, but if there's a fine-tuned universe, we're going to exist and be in it. Right? So that's a converse selection effect, and that's what's modeled in the very example you gave. If someone plays well, we're going to observe them, but that's not the real-world selection effect. The real-world selection effect is captured by my sniper example, and as you see, that doesn't remove the fallacy. Sorry, that was very long-winded, but it's a big and fascinating discussion.
My view on the fine-tuning is this, of the universe, is this. The one consciousness is fundamental. This infinite, unbounded consciousness that you and I are is fundamental. And space-time is just a headset, one of countless headsets that it's using to look at itself. So when it projects itself, it is life itself. And when it projects itself, the projection, sometimes parts of the projection make clear what is living, and sometimes it doesn't, right? Sometimes things look like rocks. Sometimes things look like living organisms. And there's an arrow of time that's part of the projection. There is no time in the one, infinite consciousness. So all of this, the notion of time, the notion of a Big Bang, an arrow of time, an evolution from less complicated to more complicated things, all of that is an artifact of the headset. The fundamental reality is this infinite life, infinite consciousness, looking at itself through a headset. And so the reason why there's the appearance of fine-tuning is because the universe is nothing but a headset of an already existing living thing that's looking at itself through the headset. So a consistent projection will be consistent with life.
Can I just interrupt? Sorry, the discussion's just getting interesting, but my little 6-year-old daughter's just come in and it's 12:45, and I think I might have to read to her to get her back to sleep. So unfortunately, we have to put a pin in that, I think.
That's no problem. It was a pleasure. And I hope to host you both on again, either together or individually. Thank you so much for coming on.
Thank you both. Always a pleasure, Kurt and Philip.
Thanks, Don. Always so stimulating. And thanks, Kurt, for probing questions and for hosting us.
The links to what everyone has mentioned, whether it's a debate between Philip and Don on Philip's channel, or whether it's the books of Don or of Philip or articles, will be in the description. All right. Thank you all for coming.
I better dash, guys. Thanks so much.
Thank you.
Okay.
Speak
Take
soon.
care. Take care.
Bye-bye.
All right, if you enjoyed that episode, then I recommend watching the Donald Hoffman episode with Yosha Bach. That was another Theolocution. There's another one with Donald Hoffman and John Vervaeke. There's a solo Donald Hoffman. That is where we go into the technical details of his fusions paper and the interface theory of perception, as well as Philip Goff will likely be coming on one-on-one, and most likely there will be a part 2 to this with Donald Hoffman and Philip Goff. So again, if you have any questions, leave them in the format query in the comments section below so that I can pose it to them, citing your name. If you'd like to see these podcasts happen with more frequency and even greater depth, then consider donating at patreon.com/KurtJaimungal. That's CurtJaimungal. We've been having a significant problem getting sponsors for this channel with monetizing, and that's a large part of any creator on YouTube. It may seem like this channel's this huge success, but it's decidedly not in the financial domain, and so your donations help tremendously, especially if you do it over PayPal, where the creator takes more of a cut, and even more especially if you do it monthly over PayPal. But again, whatever you like, whatever you're comfortable with. My wife and I both thank you. The editor thanks you. And anyhow, welcome to the new year. There are several large plans for Theories of Everything. Can't wait to announce them. Thank you. The podcast is now concluded. Thank you for watching. If you haven't subscribed or clicked that like button, now would be a great time to do so, as each subscribe and like helps YouTube push this content to more people. You should also know that there's a remarkably active Discord and subreddit for Theories of Everything, where people explicate toes, disagree respectfully about theories, and build as a community our own toes. Links to both are in the description. Also, I recently found out that external links count plenty toward the algorithm, which means that when you share on Twitter, on Facebook, on Reddit, etc., it shows YouTube that people are talking about this outside of YouTube, which in turn greatly aids the distribution on YouTube as well. Last but not least, you should know that this podcast is on iTunes, it's on Spotify, it's on every one of the audio platforms. Just type in Theories of Everything and you'll find it. Often I gain from rewatching lectures and podcasts, and I read that in the comments, hey, Toe listeners also gain from replaying. So how about instead re-listening on those platforms? iTunes, Spotify, Google Podcasts, whichever podcast catcher you use. If you'd like to support more conversations like this, then do consider visiting patreon.com/KurtJaimungal and donating with whatever you like. Again, it's support from the sponsors and you that allow me to work on Toe full-time. You get early access to ad-free audio episodes there as well. For instance, this episode was released a few days earlier. Every dollar helps far more than you think. Either way, your viewership is generosity enough.